Let's do some more work with functions, and in this case our two functions are going to be f of x equal to x squared, the square root of x plus 2, and g of x equal to the square root of x minus 3. If I'm looking at f plus g of x, there's not a lot to it. It's the square root of x plus 2 plus the square root of x minus 3. Because they're square roots, we can't combine them. But what would the domain be? The domain here would have to be, let's see here, for this, the domain is negative 2 to infinity, and for g, it's 3 infinity, right? So we're going to have to go with the higher one to keep g happy. So our domain here is 3 infinity. What about f minus g? Well, it's going to be the same thing. Square root of the quantity x plus 2 minus square root of the quantity x minus 3. And the domain is going to be, again, from 3 to infinity. F times g of x would be square root of x plus 2 times the square root of x minus 3. So that would be what? The square root of x plus 2 times x minus 3. Let's simplify that out. So that's x squared minus x minus 6. Square root of that. Now the interesting thing here is that if I take this and we let everything be like way negative, if x plus 2, if that's negative and x minus 3 is also negative, then this whole expression would end up being positive because two negatives make a positive. So if we're below negative 2, we'd be okay. So our domain is going to be negative infinity to negative 2. That's okay. And if we're both positive, that's okay too. So 3 infinity. We just can't be in this negative 2 to 3 range, because then we'd have one negative and one positive term, and that wouldn't work. That would give us the square root of a negative number. So that comes from that. And then the last one we have to look at, let's look at the quotient f divided by g of x. That's the square root of x plus 2 over the square root of x minus 3, which is the square root of x plus 2 over x minus 3. Once again, for the domain, we could have a negative divided by a negative, and that would be okay. But we couldn't have like a positive divided by a negative. That wouldn't work. That'd be no good. So our domain is similar to above. It's going to be negative infinity to negative 2 unioned with, but this time it's going to be an open interval, 3 to infinity. Why is it open? Because this can't be 0. So x minus 3 can't be 0, so x cannot be 3. Okay. And this formulation with domains and square roots is a little tricky. Let's look at another example of it. Let's take the square root of x minus 1 times x plus 1. And let's look at its domain. If I pick and I draw these zeros here, I've got negative 1 and I've got positive 1. And if I'm down here below negative 1, say at negative 2, what's going to happen is we'll have negative 3 times a negative 1 which is the square root of 3. And that's just fine. And we can have the square root of 3, no problem. So this is okay. What if I'm in here at like 0? Then that would be the square root of negative 1 times a positive 1, and that's the square root of negative 1. That's no good. All right, well, what if we're on the outside over here with x equal to 2? Then we would have the square root of 2 minus 1 times 2 plus 1. That's the square root of 1 times 3, which is the square root of 3 again, which is, once again, okay. So this region is okay. So we've got these two little transition points right here where we transition from both negative to only one negative to both positive. And it's over here in this region that we can't allow as part of the domain. Thanks. See you next time.